Hey everybody, this is a clip from a bigger video on solving systems using elimination. In this clip, you're going to see kind of a quick little practice problem with solving with elimination, and then how we have to manipulate one of the equations in order to use elimination. So this is helping to extend your knowledge and practice through elimination. I hope it helps. Best of luck. Okay, you see the system looking in problem C. You have your first equation, 2x plus 5y equals 8. You have your second equation, 2x minus 3y equals 17. To solve the system by elimination, we're first looking for the same coefficients, and you see that. There's your 2's. And so we can go through then and we can eliminate our x's. If you use what we just talked about, you'll notice that we have the same sign on both of those terms. And so for me to eliminate two of the same thing, then I need to take them and subtract. So I'm going to subtract equation 1 and 2, and I'm going to do it in that order. I'm going to take equation 1 and then subtract equation 2. Again, some people like the total line just as a visual. Okay, now I'm going to go through and I'm going to subtract each of those equations. 2x subtract 2x, those cancel out, which is great. I now have a 5y subtract a negative 3y, and there is your common mistake. Be very careful. I'm correct in me writing down 8y, but I would have bet that we would have had a bunch of people that would have written down 2y. Over and off to the side, I'm just going to write down what we just did. We are taking our 5y and we are subtracting a negative 3y. Remember, I'm subtracting my two equations from each other. And when I write that out in orange, you can see that I'm subtracting a negative, which means I'm really making it more positive. Easily, that's going to be your number one trap. So just be careful. Okay, I can now take my 8 and subtract my 17. There is a negative 9. And now I have a nice easy equation. I've eliminated. And there we go. So what I would like you to do now is I want you to finish off this system on your own. And we'll just make sure that we can drill in the second half of our solution. So I want you to pause the video now. Okay, so we're back. So now I can sub in my y equals negative 9/8. And I'm going back into one of my originals. I don't really see either of those equations as being significantly easier than the other. I think I might just go back into one only because of the 8 on the right side rather than the 17. So in order to do that, I've got my 2x plus my 5, sub in my y value, and now I have my equation with just x's. Okay, I can simplify all my terms. Then I can isolate my variable term, so I have to get rid of that negative 45/8. That means I'm going to need my common denominator, so 8 becomes 64/8. I can simplify my right side, and that gets me 109. And now when I divide out my 2, there we go. I take a look at my denominator. That's only made of 2's, so I know that that is fully reduced. And I need to remember to write my solution. Alphabetical order. And that got a little sloppy. My x value first. And my y value second with some nice ugly fractions. There we go. So I would argue to you, if we can take a look and work our way through that system, then you should be pretty confident in using elimination. Okay, the rest of our examples for today are just looking at some things. What happens if we can't eliminate something so nice and neat? Okay, let's take a look at another one. Here we go. So I want you to take a look at the system that I gave you in D. Clearly, we have equation 1 and we have equation 2. And now we're going to look to eliminate a variable. However, you may notice, right now you cannot eliminate your x's because they do not have the same coefficient. But you can also notice you cannot eliminate your y's because they don't have the same coefficient. So, up until this point, maybe elimination only seemed to you to be a viable solution or method for solution when you had the same coefficient on a variable. Well, that doesn't mean then that all of a sudden, okay, well, we can't use elimination. It just means our actions maybe have to be a little different to get us to our goal. That when we take a look at those two equations, we wish that we had a variable with the same coefficient. So our argument is going to be, well then, why don't we just make it have the same coefficient? If I take a look at equation 1, I could have my x's, a 2, turn into a 3. Because I could take a 2, and if I multiply it by 3 halves, then that gives me 3. Except, I don't think we want to be multiplying stuff by fractions and making things ugly. So, I take a look at my two equations, and I notice that if I focus in on my y's, I could make my y's have the same coefficient. If I changed equation 1 and I doubled everything. Okay, I want to have a quick discussion on that. Notice what I'm going to do is I'm going to take equation 1 and I'm going to multiply it by 2. And we should be good that as long as I do the same operation to both sides of my equation, then my equation stays in balance. So if I took equation 1 and I doubled all parts of the left side, so I doubled the entire left side, then as long as I double the right side, that equation is still true. So you take a look at that orange equation I just wrote, and then take a look back up at equation 1, and you'll notice they are the same equations, just unsimplified. Look at my orange equation again and notice that we have a common factor of 2 in each one of those equations. We could divide it out, and if we did, we get back to equation 1. You'll also notice we cured our problem for elimination. Now look at both of my y terms, and we'll see, hey, I got the same coefficient. I can now eliminate my variable. Okay, we've got some formatting. You just unsimplified an equation. That means it gets a new equation number, and man, is that a sloppy 3. So that now becomes equation 3. It's important for us to note, equation 1 and equation 3 are the same equations. But because I've unsimplified it, it gets a new equation number. And so now what I'm focusing in on, since equation 1 and equation 3 are the same equations, I'm really focusing in on this like new system. The system between equation 2 and equation 3. And now I can look at those and I can eliminate my variable. So what I want you to do is focus in on that system we just talked about, equation 2 and 3, and see if you can finish off solving that system using elimination. Okay, pause the video now. Give it a go. Okay, we're back. Now, for me to go through and solve that system, I am I don't know if I want to say believer in, but I definitely I prefer to always have positive coefficients on my variables. So I want to walk through something that can happen. If I put my little total line down again, I may choose to take equation 2 and subtract equation 3 because I see they both have the same sign on my y's. But when I do that, I'm going to get negative x equals 0, and I might not like that negative. So my focus always becomes, I really want to have a positive leading term, a positive coefficient on my variable. And so my action in this case would actually be to take equation 3 and subtract equation 2. It might seem small right now, but it's going to save me some time or some effort or some focus later on. Okay, what does that give me? Well then, my 4x subtract my 3x is an x. My 2y subtract 2y cancels out. My 6 subtract 6, there's my 0. And look, I just actually solved for what my variable is, x equals 0. Okay, I can now take that x equals 0 and I can sub it back into one of my originals. And you notice I keep saying one of my originals. I could sub it back into my orange equation because 3 is equation 1. Except, and this is an important thing for us to consider, that orange equation was manipulated, and you did the manipulation. Is it possible that you made an error when you came up with that orange equation? Absolutely yes, we are human. Therefore, my orange equation could be wrong. That means when I just solve for x equals 0, that could be wrong. And if I now took that incorrect value and I subbed it back into equation 3, I'm going to take something that's wrong and sub it back into something that's wrong. I'm going to be more wrong. I'm going to be farther away from my correct solution. And so a piece of advice I'd like to give you, sub it back into one of your originals. They were given to you. You know that they are true. So when I'm considering what equation to sub it back into, I'm considering equation 1 or 2. And in this case, equation 1, and I got to get rid of that, would be the easier of the two equations just because I have a y and not a 2y. So I'm going to sub it back into 1. 2 times 0 is 0, and that gives me a very clean equation of y equals 3. I actually have my full solution now. So I just need to remember, state my final solution, x coordinate, y coordinate, and we are good. So the takeaway from the system that we've dealt with in D is we may need to manipulate an equation first in order to get the same coefficient to be able to use elimination. Focus up on my blue on equation 1. We had to manipulate equation 1 by doubling it in order to ensure that we had the same coefficient on both variables. I think you'll still notice that still makes it pretty efficient for us to use elimination compared to, let's say, substitution. Okay, let's keep playing around with some systems like this. Here's another. Okay, let's take a look at E. You can see the system I've given you in E. Everybody should be good to label that as equation 1 and equation 2. You notice you do not have the same coefficient on your x's nor your y's, and therefore we need to figure out how we're going to manipulate those equations. So I want to give you a chance to just take a moment, try it on your own, and we'll see if we match up. So I want you to try to manipulate one of your equations to get the same coefficient in front of both your variables. Okay, pause the video now. Okay, we're back. I am really hoping that I had everybody choose to multiply equation 2 by 5. Because you would see you could multiply by an integer, and when you do that, you're going to get 5s in front of both your y's. So we can now go ahead and we can multiply everything in equation 2 by 5. We now just unsimplified equation 2, so it gets a new equation number as equation 3. And the system we are now working with is equation 1 and equation 3. Okay, I think you should be good to be able to finish off solving the system now. Let's use this as a bit of a gauge to try it on our own. I want you to pause it now and finish it off. Okay, pause it now. Okay, we're back. So we take a look at those, and it doesn't matter what order I add in. So I am going to add equation 1 and equation 3 because I notice that I have different signs on my y terms. Okay, I'll put in a little total line. And now when I add my x's, I'm going to get 17x. I add my y's, they cancel out. I add my constants on the other side. I'm going to divide that out. And actually, if I take 68 and I divide it by 17, that's going to give me 4. Nice. So I can now go through and I can sub x equals 4 back into one of my originals. And I think the easiest one to sub that back into right now is going to be equation 2 because I have a coefficient of 1 on my y. So I can replace my x with 2. There is a 12 minus y equals 12. Well, pretty quickly, when I get my 12 minus 12, I'm going to get a y value of 0. And therefore, I have my final solution. There is an x value of 4 and a y value of 0. Nice. Okay, hopefully we matched up and you were feeling much more confident in using elimination to go through and solve. Okay, here comes another one.